Bottles of Fizzo are filled by a machine. When the machine is properly set, the mean is 500 milliliters and the standard deviation is 2 milliliters. A manager is concerned that the machine is not putting enough Fizzo into each bottle and decides to test 20 bottles. He finds that the total Fizzo in the 20 bottles is 9,988 milliliters. We want to carry out a hypothesis test at the 5% significance level to see if the machine needs to be reset. When carrying out a hypothesis test, we need to have null and alternative hypotheses. The null hypothesis is called H0 and is always the situation of no change. The original situation is that the machine should be set with a mean of 500 milliliters. Therefore, the null hypothesis is that mu is 500. The manager is worried that the machine is not putting enough Fizzo into each bottle. The alternative hypothesis, therefore, is that mu is now less than 500. The volume in each individual bottle of Fizzo would be normally distributed with mean 500 and a standard deviation of 2, giving us a variance of 4. If we take samples of size 20, the means of those are distributed normally with the same mean, but the variance will become 4 over the sample size, which is 20. When we carry out hypothesis tests, we need to find a critical region. If we consider the standard normal, we have tables for the standard normal and it has a mean at 0. So this is Z, which is a normal with mean 0 and variance 1. We want to carry out a test at the 5% level, and it's a less than test, so it's in this branch. So we want the value, so that this is 5%. Looking up tables, this is minus 1.6449. I have quite accurate tables. You might not get these many decimal places in yours. We can use this to find the critical region for our test. Remember, our distribution is this one here. So we have a normal like this, with the mean at 500. The critical region would be this region here, and we want this value. Remember that Z is always equal to x take away mu, divided by the standard deviation. Rearranging and using the values we have, x is going to be equal to 2 over root 20, that's the standard deviation for this, multiplied by the Z value, minus 1.6449, plus the mean, which is 500. So our x value is 499.26. So this value here is 499.26. Anything less than 499.26 is in the critical region and is significant at this level of testing. Anything above this is not significant, and therefore we would accept H0. We have 9,988 milliliters in 20 bottles. So our mean is equal to 499.26 0.4 milliliters. That's not in the critical region. Therefore, it's not significant at this level, and we accept H0. In other words, the machine is set correctly.